This spring, during stays at the International Space Station, ESA astronauts Leopold Eharts and Hans Schlegel fitted out the newly attached European Columbus module, giving European scientists and industry their own permanent laboratory in space. Ariane 5 also launched Europe's automated transfer vehicle, the ATV dubbed Jules Verne. After remotely and safely docking with the ISS, the cargo vessel and space tug served as an integral part of the orbital complex during 5 months before its successful destructive re-entry over the Pacific. These two milestones have opened a new era for Europe's presence in space, with the aspiration to consolidate its independence.
Now what we need is to develop the last segment of this chain, which is the capability to safely bring back first samples and then humans to the Earth, and then also being able to, let's say, to operate this chain in the proper way.
ESA's Human Spaceflight Directorate has thus embarked on a proposed program to develop new versions of the ATV.
The projects we are considering are essentially based on a reuse of the service module of the ATV and the replacement of the integrated cargo carrier with a re-entry capsule. Re-entry capsule which would allow, therefore, surviving the atmospheric re-entry and bringing down to the Earth first some cargo and then in the future a complete crew.
Over the past decades, Europe has demonstrated the technologies of spacecraft re-entry and crew transportation, notably with the retrieval in 1998 of the atmospheric re-entry demonstrator, proving that it masters the thermal issues of a capsule's safe return to Earth.
This experience will be a very good starting point for an evolution of the ATV going to a re-entry capsule, because will give us data for the validation of our models, but also will provide a very good basis in terms of materials selected for the thermal protection system.
ESA and its industrial partners will have to develop new technologies to satisfy other crucial requirements, such as the ejection system to ensure the absolute safety of a space capsule's crew in case of an anomaly on the launch pad or during the ascent phase.
L'idée d'un système d'éjection, c'est de vous éloigner suffisamment rapidement.
This is to distance oneself very quickly. We use a criteria of 300 meters in just 3 seconds so that the crew is safe in case the launcher explodes.
D'un risque d'explosion du lanceur.
All this work responds to an essential question. How should Europe position itself for the future of human spaceflight and exploration? Europe believes it should play a role commensurate to its wealth and possibilities in endeavours that will mark this century. It must now secure the industrial and human expertise that has been built up over the years. It should now prepare itself to seize opportunities offered by international efforts allowing humans to explore the universe. If we do nothing now, then we'll be dependent upon our partners in any decision to pursue or not our own program of manned flights. A key to success will then be the notion of evolution, a step-by-step approach that is compatible with Europe's technical and financial resources and with a realistic calendar.
The first element will be a cargo download system. We hope to be able to launch it in 2015 to the station, and after that we will, let's say, work on the crewed version in order to have European citizens flying in an autonomous way by 2020.
These proposals for an evolution of the ATV will be on the agenda of the upcoming Council of European Space Ministers. When they meet in The Hague, their vision and their decisions will pave the way for this new era of Europe's presence in space.